This is Group 1. Our subject is 3D printing technology with Greg Hutchinson, Reggie Paramore, Corey, and Julie Skinner.
History and development of 3D printing. 3D printing can be traced back to 1984, where Charles Hall invents stereolithography, which is a printing process that enabled a tangible 3D object to be created from a digital data source. In 1992, 3D Systems, which was co-founded by Hall, creates the first SLA machine, which used a laser to solidify the polymer to create the 3D object. While not perfect recreations, this led to the ability to create complex parts overnight. And in 1999, scientists at Wake Forest Institute for Regenerative Medicine used 3D printing to create synthetic scaffolds coated with the cells of the patients and urinary augmentations in children. This enabled the crossover to health, which we will actually talk about later as well. In 2002, Wake Forest again was using the technology and created a functional kidney that was used in animals that was able to filter blood. Between the years 2000 and 2010, open source projects were designed around the creation of self-replicating printers through what was called the RepRap project. In 2009, a company called MakerBot Industries releases a do-it-yourself kit that enabled anyone to buy and make their own 3D printers and products at home. In 2011, the University of Southampton makes a 3D printed robotic plane. At the cost of only 5,000 Great British pounds and 7 days of manufacturing time, to enhance aerodynamics, the plane was able to be made using elliptical wings, which is normally a very expensive feature, but with 3D printing was able to be made faster and cheaper. Also in 2011, Core Ecologic, a car company, creates the first 3D printed car. While not very pretty to the eyes, it was still capable of making up to 200 miles per gallon highway rating. Currently, with the use of 3D printing, houses can be actually created in as little as 24 hours at a cost of about $10,000. Currently in El Salvador, there's a project going on to create houses for 100,000 residents. Next, we'll talk about the cost, benefits, and risks. Currently, costs can actually vary widely depending on the type of material that's being printed. Currently, you can have plastics and also metals that can be printed using 3D printers. Personal 3D printers can range anywhere from $220 to as high as $10,000, while industrial printers can range roughly from about $5,000 upwards of $500,000. Next, we'll talk about benefits. Benefits are able to actually lower the turnaround time on your items that you're creating, which helps create efficiency and the ability to realize quick return on investments. The ability to quickly turn around enables you to have inception to creation of an idea very quickly. And next, we'll talk about the risks. One of the major risks would be with intellectual property. The ability to grab the plans from someone else and actually create your own 3D printed item does actually have patent infringement ideas. Also, another thing is the usage of electricity. Unfortunately, with 3D printing as it stands, it uses about 50 to 100 times more electricity than the injection of molding plastics that is used currently in most industries. The amount of energy can be used, unfortunately, to create higher emissions through more energy production. Another thing is the airborne particle emissions. A home user 3D printer can actually release up to 200 billion particles per minute.
Industries. Top 3D printing industries: space industry, NASA, aircrafts, jewelry, health sector, mechanical engineering, construction, marketing, novelties. Now here I have a video that I personally believe that'll be the most impactful within the 3D printing.
X-ray was the first form of medical imaging available to clinicians. Penicillin, the miracle drug of the 20th century, was the first antibiotic. Today, around 5,000 transplants are performed each year. And mapping the human genome has given us a blueprint for human life. Today, 3D printing technology is finding a host of medical applications.
3D printing can help medical application in saving time or risk, or make the patient life easier or more comfortable. We actually use technology to really create a custom-made jacket which would help the little girl to recover her moving arms.
3D printing has simplified the customization of complex devices for a range of medical uses.
So when you think about cranial fractures, you can use 3D printing as a tool to do the dry run for the surgeon without having to make the patient suffer or take any risk in the operations.
And now the technology is being used to create more complex structures.
What we're talking about doing here is trying to make liver cells as an alternative to getting them from cadavers. We're trying to print them together on a scaffold to create little mini livers that could be a model for a liver for drug discovery. But going on from that, being able to create mini livers that one could put in and then take out of the body readily for purposes of helping address acute liver failure. I think we are going to live in an age where there would be simple organs off the shelf available for the health service to provide. If we want to go beyond that and try to create kidneys, hearts, then I think it's going to be even longer. This is no longer going to be our generation, it's our kids' generation.
Impact on business models. Here we have 4 different components: customers, finance, capabilities, value proposition. With customers, you will go from mass market to individuals. Finance, you go from high fixed costs, low variable costs, to low fixed costs, high variable costs. With the capabilities, you go from supply chain that provides sub-assemblies to a supply chain that provides raw materials. And with value proposition, you go from mass produced to on-demand customization. Now going on the positive impacts of 3D printing. As you may see, manufacturing options are only limited by imagination. You have rapid prototyping maneuvering from design to stage quickly. Manufacturing speeds are shortened periods of time making the product. You have cost reduction and affordability. Warehousing, less inventory, and less overproduction. There's more jobs for engineers, technicians, designers, and artists. Medical customizable body parts and organs. Better safety when creating parts. And STEM education. The negative impacts of 3D printing. There will be fewer manufacturing jobs, reducing the need for craftsmanship, as well as copywriting problems, lawsuits, and infringements, in which we will speak on a little bit later. And the ability to print dangerous items like guns or any other forms of weapons.
Next, we will discuss the relevant IT components of 3D printing technology when it comes to information systems. There are 5 components that make up an information system. Hardware, the physical technology that works with information. Software, the brain behind the hardware. There are 2 types, system software and application software. Data, you can think of data as a collection of facts. Alone, data is not very useful. However, when it is aggregated, indexed, and organized together into a database, it can be a powerful tool for organizations. People, the end users of the product or service offered by the information system. And lastly, process and procedures. A process is a series of steps undertaken to achieve a desired outcome or goal. A procedure is used as rules or guidelines for using the software, hardware, and data. To fully understand an information system, one must understand how all of these components work together to bring value to an organization. Now, let's take a look at these 5 components individually. The first component I will discuss is the hardware component. Hardware is the physical components of the technology. To begin, it is important to note that there are many different types of 3D printing technology out on the market today, from fused deposition modeling, FDM, stereolithography, SLA, as mentioned earlier, and selective laser sintering, SLS, just to name a few. For the purposes of the relevant IT component section, I will focus on the most common and cheapest types of 3D printing technology on the market, which is FDM printing. So, if your organization would like to utilize 3D printing technology to add value to its business, the only hardware you would need to implement this technology is a computer, an SD card, and a 3D printer. The computer is required to create or obtain the model for the 3D printer and transpose that model into G-code, which is a language the 3D printer understands. The SD card is used to save the G-code from the computer and then transfer over to the 3D printer through an SD port. Lastly, the 3D printer takes the G-code from the SD card and then creates your 3D print. To dive into 3D printing technology a little deeper, I will discuss the physical components that go into making a typical FDM 3D printer. This is useful to know if you would like to build a 3D printer from scratch for your business. So, in a typical FDM printer, you will find the following components. Filament, which is the material used to create the 3D print. It's typically a plastic type material. A hot end. This is the part where the filament is melted and extruded into tiny layers. The nozzle, which is the tip of the hot end where the filament comes out. This portion of the extruder determines the size of the filament that comes out. This size usually varies between 0.25 millimeters to 0.75 millimeters. As you can see, that's a pretty small size. The extruder is the part that feeds the filament into the hot end. Next, we have the cooling fan. These assist in keeping the temperature of the extruder and all related elements consistent. This ensures that the 3D print will have top quality features such as intended sharp edges and good bridging capabilities. Next, we have the print bed. This is the part where the filament is deposited to create the 3D object. Typically, this area is heated, which helps keep the plastic warm during the printing process, and it prevents the plastic from warping. A heated print bed is crucial for ensuring the first layer of the print provides a good foundation for the remainder of the print. Lastly, you have the LCD display. This is the controller of the printer, which allows you to print without the need of a direct computer or using a software host. All it needs is an SD card reader to provide the printer G-code instructions. The next component I will discuss is the software component of the 3D printing technology. If your business is trying to implement FDM 3D printing technology, there are 2 critical types of application software you need in order to use your 3D printer. The first type of application software you need is design software, which will provide you the platform to design the actual model you need to print. This software will allow you to custom make anything you need to 3D print for your business. This design software is typically referred to as CAD, Computer Aided Design Modeling Software. Some typical CAD modeling software brands you can find on the market today include Autodesk and SolidWorks. The next type of critical application software you need is a slicing software. This software takes the model you want to print and translates it into a language the 3D printer can understand, which is G-code, as we mentioned a few times earlier, which is essentially a roadmap of GPS instructions telling your printer how to lay out the design on the print bed. The software can also help you fabricate supports for your design, to ensure that overhangs do not get gunked up and the print quality of your model will be top-notch. One popular slicer software you can obtain online for use is called Slicer, which is completely open source. The next component I will discuss is the data component. As previously touched on in the software component section, modeling files as well as G-code files are critical for the use of 3D printing technology. Slicing software will first take the model file, typically called an STL file, and convert it into G-code for the 3D printer. An STL file consists of a set of tessellated surface data points that builds the outer surface of a 3D model. A G-code file consists of a dataset of G and M commands that have an assigned movement or action for the 3D printing machine. For a business looking to heavily implement 3D printing technology into their daily operations, the manager should consider adopting a 3D printing data management system. This system can be used to create, retrieve, update, and manage all relevant 3D printing data that the company needs. They need to also consider keeping the system internal due to cybersecurity threats. A lot of 3D printing technology is currently open source, which can lead to intellectual property and security challenges for the business. Having a secure and constantly monitored internal data management system, a company can feel safe knowing that their critical product designs won't be stolen or altered by cybercriminals. Next, I will briefly discuss the people component of 3D printing technology when it comes to information systems. People are the end users of 3D printing technology. If businesses want to implement 3D printing technology, they need designers to model the products to be printed. They need technicians to maintain the 3D printing technology hardware. They need programmers, IT specialists, and systems analysts to maintain the 3D printing software and database management systems. Additionally, management needs to be involved all the way up to the CIO to ensure the 3D printing technology is being utilized to its max potential to create value for the business. The last component to discuss is the process and procedures component. A company or firm looking to implement 3D printing technology needs to come up with a few business processes and procedures for that technology. For example, the firm needs to come up with a process and procedure for how 3D models should be performed, how the information is stored, how the information is communicated to other departments or customers, and more. Having processes and procedures in place with regards to 3D printing technology provides a way to communicate and apply consistent standards and practices across the business. This will empower the people performing the task, increase efficiency, as well as ensure consistency in the results. Now, having discussed the relevant IT components, here's a short clip of an FDM 3D printer in action.
Next, we'll talk about disruptive technology. With 3D printing, there's an opportunity to shift towards localization and locally manufactured goods. By comparing the traditional and 3D printing supply chain, there are evidently fewer agents in the 3D printing supply chain than a traditional supply chain. Some of the benefits the supply chain sees from 3D printing include shorter time to market, mass customization, localization, and reduced wastes. Hasbro, the toy company, is an excellent example as they have introduced 3D printing into their strategy by offering a wide range of customizable 3D printed toys for consumers. Some of the negative impacts to the supply chain include loss of jobs and localization. Localization is both a benefit and a concern because some of the risks include with localization are unregulated products, potentially harmful products, and copyright infringements. Next, we're going to look at the projected market growth for the 3D printing market. The 3D printing market on a global scale is estimated to be worth $8.41 billion by year 2020. The main driving factors responsible for the explosive growth of 3D printing market include new and improved technologies, variety of materials ranging from polymers to living tissue, supportive regulations, government funding, and a huge untapped market. Asia is the fastest growing and most promising market for 3D printing. However, Europe is hot on their tail, expected to surpass them in the year 2020. Next, we're going to talk about the future of 3D printing. NASA scientists are currently developing 3D printed food as an answer to food shortages. In the manufacturing world, 3D printing is revolutionizing the way parts are produced in the industry. In bioprinting, 3D printing allows people to print organs and living tissues through this technology. And finally, prototyping is a way researchers and business industries can make any amount of prototypes with ease. In conclusion, 3D printing technology is on the brink of revolutionizing and reshaping the world. Advances in 3D printing technology can significantly change and improve the way we manufacture products and produce goods worldwide. The last industrial revolution led to the world mass production and the advent of economics of scale. The digital 3D printing revolution can bring mass manufacturing back full circle to an era of mass personalization and a return to individual craftsmanship.
Here are the references for this group project.